Cyber incidents within critical infrastructure are an unfortunate reality. After all, with increased connectivity comes increased risk. If you connect it, you need to protect it. Let's review how these cyber incidents happen and what you can do to lower your risk. We're going to use manufacturing as our example, though what you'll see applies across critical infrastructure sectors. Here, we're looking at the manufacturing world outside a plant. The groups you see here run the business. Their computers and networks are considered IT, information technology. Securing IT is about protecting information, like HR data, customer data, and financials. Many organizations have mature IT security practices, employing tools like next-gen firewalls, encryption, and application security. But inside the plant is a cyber-physical world, where technology interfaces with moving machines. It's called operational technology, or OT, and is different from IT. Machines and control systems are 20 or 30 years old or older. They're rarely patched, and they were designed before the internet, the cloud, and big data were commonplace. Securing OT is about protecting control over the cyber-physical, like welding robots, dam floodgates, and in this example, production lines. The goal is to protect people, production, and assets. To illustrate what we mean by OT, let's look at the layers we see in a plant. The point of entry from the IT enterprise network is called the demilitarized zone, or DMZ. It bridges the worlds of IT and OT. Here, systems aggregate business information and deliver it to the enterprise. One level down is the process control network of human-machine interfaces, or HMIs, engineering workstations, and the engineering server. This is where operators send commands through a plant-wide SCADA network out to the programmable logic controllers, or PLCs, that control the machinery. On the production lines, the PLCs and other embedded components enable real-time production control. They are very simple machines that are now being connected widely for monitoring, control, and optimization. We often see this connectivity via backdoors. At the bottom right is an integrator or vendor remoting in through a connection that may be unpublished and unmaintained. So how do you protect this OT environment? It's vulnerable, it's cyber-physical, and it's critical to the safety and quality of life of billions of people. Well, the first step is visibility. You can't protect what you don't see and understand. The purple dots that just started zipping around represent IT traffic. Companies have good IT network visibility. They know what's happening on their enterprise networks. It helps that they've had decades of IT maturity and that they speak the standardized languages of IT, like IP, HTTP, FTP, and others. But companies rarely have the same level of visibility into their OT networks where production is happening. We often find that companies don't know what equipment is talking to what other equipment, which commands are being issued, and what exactly is connected to the OT network. One of the biggest barriers to OT network visibility is that OT speaks different languages, called protocols, than IT does. Protocols like DNP3, HL7, and OPC Classic are unique to OT, and without speaking the language, it's nearly impossible to put intelligent protection in place. We just deployed Wurdltech's OpShield in this production environment. OpShield is purpose-built for industry, so it can read OT protocols fluently down to the command level. That powers a whole set of OT cybersecurity capabilities. Notice that 3 of the commands, they're all visible now that OpShield's deployed. 3 are marked with exclamation marks. When you understand the OT commands as well as their context, you can look for suspicious commands and create policies to block them. Or you can even whitelist, which means blocking everything that doesn't match a detailed OT-specific policy. Also note that the engineering workstation turned red. Often our initial OT network scans, after deploying OpShield, reveal 1 or more existing infections that were unknown to the system operators. We'd be happy to get into detail about OT command support, command level whitelisting, and even Turing complete signature processing, but for the sake of time, let's walk through an OT cyber attack and show how OpShield can help prevent it. These are some of the entry points for attackers. They're called attack vectors, and together they form the attack surface. We're going to focus on a common vector, removable media. We will use the cyber kill chain concept to walk through the steps of an attack. In this case, a worker inserts a USB stick into the engineering workstation. This stick happens to house malicious code that's part of an attack designed to stop production and damage equipment. The malicious code compromises the engineering workstation, establishing a beachhead on the OT network. The code then shifts to reconnaissance, using the workstation to scan for connected machines. Spotting the engineering server, the attacker uses a low-level exploit to install tools and complete the compromise. From the engineering server, the attacker repeats the reconnaissance process, this time with different tools tailored to the functionality and vulnerabilities of factory floor systems. With the information gathered, the attacker identifies a specific PLC as the next target and gathers the tools necessary for the next step. The attacker exploits a PLC vulnerability, obtaining control and modifying its logic, in this case to stop production by running a motor beyond its parameters. This causes unplanned downtime, notice the production has ceased, possibly combined with a safety incident, and asset damage, and certainly revenue loss. In cyber incidents like this, companies are often left wondering what happened. The incident is usually mistaken for mundane, routine failure, only later to be recognized as an attack or misconfiguration. Now let's run through a short version of that same scenario, this time with OpShield deployed. OpShield is designed to disrupt the attack cycle and isolate compromised systems. These are critical tasks in OT. It's disrupting the attack cycle and isolating these systems, because the only effective OT security posture is to operate under the assumption that infections will eventually occur. So replaying the attack scenario we just walked through, OpShield intercepts the exploit that's designed to compromise the engineering server. Write is a valid command, but the combination of source and destination, the parameters of that particular data flow, and other contextual indicators cause OpShield to correctly block and flag that command in that context. Deployed within the operational environment as shown, OpShield can also detect a malicious command from the engineering server to the PLCs if an attack made it that far. In either case, OpShield alerts the Wurdltech IMSS, which is the Industrial Managed Security Service we offer, or other Security Operations Center, SOC, which responds to the incident. While all this is happening, production has never stopped. That averts lost revenue, safety incidents, and asset damage. I hope that this has been helpful. We've shown that operational technology, or OT, lacks the network visibility necessary to protect people, production, and assets. And you saw that OT-specific cybersecurity with policy and deep command-level inspection is effective within an operational environment. Remember that if you connect it, you need to protect it.